Sponge cities. Approaches to building low-impact development rainwater systems. Concept of low-impact development rainwater systems. Low-impact development refers to using decentralized, source-based measures during site development to maintain the pre-development hydrological characteristics of the site. This approach is also known as low-impact design or low-impact urban design and development. The core principle of LID is to keep hydrological features unchanged before and after development, such as total runoff volume, peak flow rate, and time to peak. Second, basic principles for constructing LID rainwater systems. Planning guidance. The construction of sponge cities and LID rainwater systems should be integrated into all levels of urban planning and related professional fields, as well as subsequent construction procedures. The process should be guided by scientific and authoritative planning to ensure that construction follows a well-established plan, emphasizing the control and leadership role of planning. Ecological priority. Urban planning should scientifically delineate blue and green lines. Urban development should protect water-sensitive areas, such as rivers, lakes, wetlands, ponds, and channels. Natural drainage systems and lift facilities should be prioritized to achieve natural water storage, infiltration, purification, sustainable water circulation. This approach enhances the natural restoration capabilities of the water ecosystem and maintains the city's ecological functions. Safety first. The primary goal should be to protect people's lives, property, and socio-economic stability. Both engineering and non-engineering measures should be applied to improve the construction quality and management of LID facilities, eliminate safety hazards, enhance capabilities of disaster prevention and mitigation, and ensure urban water safety. Adaptation to local conditions. LID goals and indicators should be determined based on local natural geographic conditions, hydrogeological features, water resource endowments, rainfall patterns, water environment protection, and flood prevention requirements. The scientific planning and selection of LID facilities, such as sunken green spaces, vegetated swales, rainwater wetlands, permeable pavements, and multifunctional storage systems, should be tailored to local conditions. Coordinated construction. Local governments should integrate the overall planning and construction of the city to ensure that LID control goals in various levels of relevant planning are strictly implemented. In all construction projects, LID facilities should be planned, designed, constructed, and put into operation simultaneously with the main project works. Third, approaches to constructing LID rainwater systems. In the process of urban construction, it is essential to integrate LID concepts into all stages, including urban planning, design, implementation, and operation. This requires the coordinated efforts of various professionals in urban planning, drainage, landscaping, transportation, architecture, and hydrology to collectively achieve LID control goals. Urban planning at all levels should adhere to LID principles by setting clear control goals for low-impact development. These goals should be aligned with the characteristics of the development area or project, and corresponding planning control indicators should be established to ensure that key aspects of LID construction are implemented. Overall, urban planning should innovate planning concepts and methods, making LID rainwater systems a crucial part of new urbanization and ecological civilization. Detailed planning, regulatory and construction-specific planning ensures that the LID control goals and indicators set by the overall urban plan and related specialized plans are implemented. In cities or new districts where conditions allow, a specialized rainwater control and utilization plan based on LID principles can be developed. For instance, rainwater can be collected for use in landscaping irrigation, water features, firefighting and construction activities, engineering design, During the design phase, it is important to scientifically and rationally plan both the horizontal and vertical aspects of various live facilities and their combinations. In the planning and construction of buildings, residential areas, urban roads, green spaces, plazas, and water systems, open spaces like landscape water bodies, and waterfront areas should be considered. For LID facilities and rainwater system, new, renovated, and expanded projects suitable for the rainwater systems should clearly incorporate the design elements in their landscaping, transportation, drainage, and architectural design plans. This ensures that the lead control goals are effectively implemented. The main design process for the rainwater systems should be followed as illustrated in the design flowchart. Examples of lead design elements include rain gardens along streets and ecological drainage ditches, construction and implementation. The construction of the rainwater systems is closely linked to the planning control objectives and meteorological conditions and land use characteristics of the area. Therefore, when selecting the process, individual facilities, or combination systems for the rainwater systems, it is essential to conduct a technical and economic analysis and comparison to optimize the design plan, the scale, vertical and horizontal layout of the LID facilities should be strictly controlled according to the planning and design documents. There should be a quality control and inspection system, specifically for lead rainwater systems at the construction site. All materials, semi-finished products, components, and equipment used for lead facilities must be inspected and accepted upon arrival at the construction site following relevant requirements. Effective soil and water conservation measures should be implemented to minimize the disturbance and damage to the site and its surroundings during construction. In regions where conditions allow, the acceptance of lead rainwater facilities can be conducted after the entire project has undergone a rain season to test its effectiveness. The construction of sponge facilities differs from traditional engineering methods, and inadequate quality control during construction can lead to inconsistent performance of the facilities. Maintenance and management. After the completion of lead facilities, it is crucial to clearly assign maintenance and management responsibilities to specific units and ensure that personnel are in place to oversee these facilities. The routine maintenance and management tasks should be detailed to ensure the correct operation of facilities. A comprehensive maintenance and management system should be established. This includes appointing dedicated management personnel, equipping them with appropriate monitoring tools, and providing professional technical training for both management and operational staff. Regular inspections and maintenance of the facilities should be conducted before and during the rainy season to ensure the safe and effective operation. The development of databases for lead facilities and the application of information technology should be enhanced. By utilizing digital information technologies, scientific planning and design can be conducted, providing a solid foundation for the construction and operation of lead rainwater systems. Moreover, it is essential to strengthen public awareness and education regarding the importance of rainwater control and utilization in sponge city construction, LID, green buildings, urban water conservation, water ecosystem restoration, and flood prevention. Public participation in the construction, operation, and maintenance of lead facilities should be actively encouraged.